The Northern Lights, also known as the Aurora Borealis, are one of the most mesmerizing natural phenomena visible in the Earth's skies. Their vivid colors, swirling patterns, and mysterious origins have fascinated humans for centuries. Today, we're going to delve deep into the science, history, mythology, and cultural significance of the Northern Lights. By the end of this lesson, you'll have a comprehensive understanding of why and how they occur, where you can see them, and their impact on human culture and scientific exploration. First, let's begin with the basics of what the Northern Lights actually are. The Aurora Borealis is a natural light display that occurs in the high-latitude regions near the Arctic Circle. Its southern counterpart, the Aurora Australis, is seen near the Antarctic Circle. These lights are caused by interactions between charged particles from the Sun and the Earth's magnetic field and atmosphere. When these particles collide with gases like oxygen and nitrogen in the Earth's upper atmosphere, they produce the vibrant colors we associate with auroras. The primary colors of the Northern Lights are green, pink, and red, but shades of yellow, blue, and violet can also appear under certain conditions. To understand the Northern Lights more fully, we must explore their origins in space. The Sun, our closest star, is a massive ball of plasma made up of hydrogen and helium. Through a process called nuclear fusion, the Sun generates immense amounts of energy, some of which is released as solar wind. Solar wind consists of charged particles, including electrons and protons, that travel outward from the Sun at incredible speeds. When a strong solar wind reaches Earth, the planet's magnetic field acts as a shield, deflecting most of these particles. However, near the poles, the magnetic field is weaker, allowing some particles to enter the atmosphere. Once these particles penetrate the Earth's magnetic field, they collide with molecules of oxygen and nitrogen in the upper atmosphere. These collisions transfer energy to the atmospheric gases, exciting their atoms and causing them to emit light. Oxygen produces green and red light, depending on altitude, while nitrogen contributes to blue and purple hues. The specific colors and patterns of the aurora are influenced by factors such as altitude, the composition of the atmosphere, and the intensity of the solar wind. Now let's move on to the geographical aspects of the Northern Lights. The best places to observe the aurora are within the so-called auroral oval, a region encircling the geomagnetic poles. Countries like Norway, Sweden, Finland, Iceland, Canada, and Alaska in the United States are among the prime locations for viewing. The lights are most vivid during the winter months, when nights are longer, skies are darker, and solar activity is higher. Auroras are generally more intense during periods of heightened solar activity, such as during a solar maximum, which occurs roughly every 11 years as part of the Sun's natural cycle. The history of human interaction with the Northern Lights is rich and varied. Ancient civilizations often interpreted the aurora as supernatural phenomena. For instance, the Norse people believed the lights were reflections from the shields of the Valkyries, warrior maidens who guided fallen warriors to the afterlife. The Inuit people of North America thought the lights were the spirits of their ancestors playing games in the sky. In China, the aurora was sometimes seen as a celestial dragon breathing fire, a symbol of both power and chaos. In more recent history, scientists began to study the aurora with the tools of modern science. In the 17th century, the term aurora borealis was coined by the Italian scientist Galileo Galilei. combining the names of Aurora, the Roman goddess of dawn, and Boreas, the Greek god of the north wind. The advent of photography in the 19th century allowed for detailed documentation of the phenomenon, and advances in space science during the 20th century provided a deeper understanding of its origins. The cultural significance of the Northern Lights extends beyond mythology and science. Artists, poets, and writers have often drawn inspiration from the aurora's ethereal beauty. For instance, the Romantic poets of the 18th and 19th centuries frequently referenced the lights in their works as symbols of nature's power and mystery. In modern times, the aurora has been featured in films, music, and literature, often serving as a metaphor for wonder, discovery, and the unknown. Beyond their cultural impact, the Northern Lights have practical scientific significance. Studying the aurora helps scientists understand the interactions between the Earth's magnetic field and the solar wind. This research is particularly important in the context of space weather, which can have significant effects on modern technology. Solar storms, for example, can disrupt satellite communications, GPS systems, and even power grids on Earth. By monitoring auroras, scientists can gain insights into these events and develop strategies to mitigate their impacts. Now that we've covered the scientific and cultural aspects, let's discuss how you can experience the Northern Lights for yourself. To maximize your chances of seeing the aurora, you need to be in the right place at the right time. As mentioned earlier, high-latitude regions near the Arctic Circle are ideal. Look for clear, dark skies away from city lights, as light pollution can obscure the view. Winter is generally the best season, although the aurora can occasionally be seen during other times of the year. Patience is key when aurora hunting, as the lights can be unpredictable. Checking the aurora forecast, which provides information on solar activity and geomagnetic conditions, can help you plan your viewing experience. Some websites and apps offer real-time updates and alerts for when auroras are likely to be visible in your area. Finally, let's touch on some related topics to round out our understanding of the Northern Lights. One important concept is the Earth's magnetosphere, the region of space dominated by the planet's magnetic field. The magnetosphere plays a crucial role in protecting the Earth from harmful solar radiation and in shaping the behavior of the aurora. Understanding the magnetosphere is also important for space exploration, as it influences the trajectories of spacecraft and the safety of astronauts. Another related topic is the phenomenon of geomagnetic storms, which occur when the Earth's magnetic field is temporarily disturbed by a surge in solar wind. These storms can intensify the aurora, making it visible at lower latitudes than usual. However, they can also pose risks to technology, as mentioned earlier. Studying geomagnetic storms is an important area of research in both space science and engineering. Let's also consider the role of technology in aurora research. Instruments like spectrometers, magnetometers, and all-sky cameras are used to study the aurora in detail. Satellites, such as NASA's Themis mission and the European Space Agency's Cluster mission, have provided valuable data on the interactions between solar wind and the Earth's magnetic field. These technological advancements have deepened our understanding of the aurora and its connection to broader space weather phenomena. Lastly, we can't ignore the economic and tourism aspects of the Northern Lights. In countries like Iceland, Norway, and Finland, aurora tourism is a significant industry. Visitors from around the world travel to these regions to witness the lights, often combining their trips with other winter activities like dog sledding ice fishing and staying in glass-roofed cabins designed for aurora viewing. This has brought economic benefits to these areas, though it also raises questions about sustainability and the environmental impact of increased tourism. In conclusion, the Northern Lights are not just a breathtaking natural spectacle. They are a window into the complex interactions between our planet and the cosmos. From their scientific origins to their cultural significance, from the myths of ancient civilization to the cutting-edge research of today, the aurora continues to captivate and inspire us. Whether you're an artist, a scientist, or simply a curious observer, the Northern Lights offer a profound reminder of the beauty and mystery of our universe. I hope this lesson has illuminated the many facets of the aurora and deepened your appreciation for this extraordinary phenomenon.